Alright guys, how's it going? We're back again. Today we want to get into another technical topic, alternators. So, checking over the logs lately, I've noticed voltage has been an issue above like X amount RPM. And we've killed like 2 alternators in the past month. So, I did a deep dive, which I'm known for doing, into alternators and how to keep them alive, the do's and don'ts, pulley ratio, which I've never thought of before. In my head, you could have just spun an alternator as high as you can and it'd be fine, right? Well, no, that's not the case. Apparently, on certain style alternators, the alternators that we are dealing with in today's video, Hondas in general, 20,000 RPMs is max. You really want to spin these things. Everyone else really says 18,000 RPMs at the alternator itself. And the way you find that RPM of the alternator is you check out a pulley ratio chart. So what we are looking at here, we have the crankshaft pulley diameter. The one we're using is 6.75, so 6 3/4 inch. Now previously we had a 2.0 pulley on the alternator here, right? So then if you match these up, your pulley ratio comes out to 3.38. Now if we multiply 3.38 times, let's see, the idle of the car, we'll say it idles at 1600 RPMs. So that's 5,000 RPM just at idle on the alternator. Now I believe it takes like 1,000 RPMs for an alternator charge, something like that. I may have to go back and check that, but let's see. We're spinning the new engine like 10,000 RPMs, correct? So that means that we were spinning that alternator 33,800 RPM, and they basically stopped working. So they basically stopped working around 18,000 RPMs. So what we need to do to correct this is change the pulley size on the actual alternator. Now this is the alternator that I'm going with. We'll get into that in a second. You can see the size difference, how much smaller this guy is. The reason I went with this was to get it away from the heat. Anyways, like I said, in a second. So this is a 3.5 inch pulley. So if we jump down here, well, on this column, we jump all the way down here. We're switching to a 1.93 just by switching the pulley. So let's clear all of this and go 1.93 times 10,000 RPMs, and we're at 19,000 revolutions per minute at the alternator. So that's at its peak, its max, but it's much closer to being its operating range. And if we're worried about idle, let's say 1600, we're at 3000. I think it's 2000 RPM, now that I think about it, is what kicks it off to do the charge. So switching to this much bigger pulley is going to hopefully get us an alternator that's going to last longer, perform better, sustain voltage all the way through the pool, down track, everything we need it to do. So this is the traditional OEM alternator that comes off the Prelude, the H series. What I'm doing is getting rid of this big heavy dude, and I'm switching out for this small, compact, excess volt Power Master alternator. So this doesn't have a connector, it's a 1-wire alternator, so I don't need to run a any connector to it, just the main power wire. Now this is a ground post. We're going to ground this directly to the battery. We are still going to let it ground through the engine as well. That is fine. But this guy will work once it has voltage and ground and this pulley starts spinning. So my issue with switching to this custom alternator, well, it's not going to fit my bracket. So I've been wanting for a long time to kind of figure out Fusion 360, and as my deep dives go, this is like the third or fourth rendition of this, but I have made an alternator bracket, as you'll see here in a second when we head up to the garage. I had my buddy at work 3D print me a couple of templates. This was just to confirm bolt spacing, and then maybe for me to see how far these tabs need to go on. First try with using a tape measure and converting some stuff to metric. I got the bolt holes lined up pretty good, so I left that alone. And then we switched to this. I know the arc of this because of the bolt spacing here to here, you know, the measurement here, so then you can just draw big circles and then circles and circles and a lot of circles and make this stuff work. This was really flimsy and I think it had it pushed too far out, so we had another rendition printed, that's out in the garage, I'll show you that in a sec, which brought it back. And then we ended up, I was wanting to do this out of aluminum so it would be lighter. I have that file if that does come to fruition in the future. To get the ball rolling faster, I did modify everything. I split these bodies apart, and I made 3 separate bodies to where they go inside of each other right here. Let me see if I go to my bodies. So that's a body and then this is a body, so I can pull these apart from each other, and I saved them as different files, and then I sent the file to Send Cut Send, and I got back 3 pieces of 1/2-inch mild steel. I know it's pretty extreme, it is really heavy, but in the past I've had issues with this stuff warping. So I left a little recess on the back here to where I could weld on the inside, and we got the bracket out in the garage all welded up, as you guys will see here in a sec. So yeah, we got us an alternator bracket. Everything works great with this guy, everything lines up. We just have to get a couple things sorted on the car, and then we will get this into testing. So that's where we're at alternator wise. All right guys, we got a package in the mail today from Send Cut Send. I had 3 pieces cut out of a laser cutter that I designed in Fusion 360. And I'm gonna try to tack this stuff together. I'm gonna do tack on the face on each side, and I left a recess so I can weld in the back as well. We're just gonna tack both of these on and test fit, make sure everything's looking good, and go from there. little feller on here. We got a lot more room. I can fit all my fingers in between the manifold now. Before you could barely put a piece of paper. So this alternator is definitely smaller. Definitely smaller. The end of the adjustment is still a little long. So if I redo this for any reason, I'll know I can adjust that. But also in the same sense, if I go to a longer belt for any reason, I'll be able to tension this up higher. So I don't know, I might leave it. I might take it back another ½ inch or ¼ inch or something. But yeah, she's looking good. This is your ground wire. I'm just mocking up here. The only thing that I'm seeing currently with it just tacked on is the alternator is maybe ever so slightly cocked this direction. If you put, I was using this T or 90 as a straight edge and putting it flush on this pulley, and it was kind of intersecting the belt. So what I think I'm gonna do before I final weld it is my next welds are gonna be on the inside of the bracket on the face right here. If I put those welds right there, that'll pull everything towards the turbo manifold, which should straighten it out. I'll do both of those, and then I might put it back on, see if that corrected it, and then take it back off again and final burn in the outside and then the rest of it. And then I think that should honestly like get me right where I want to be. So pretty excited so far. Seeing your creation come to life is pretty awesome. I never thought I'd be able to mess with that program, and you know, a lot of frustration, but you know, you just got to get in there and get after it, and then eventually you'll figure it out. So all right guys, this was the final rendition. If I did do it out of aluminum, it's got a bunch of nice supports and gussets and stuff like that. Everything looks really nice. This was the original guy that has been re-welded 1,600 times. I was super over that. One thing I did forget to mention about this Power Master XS Volt alternator, this is an adjustable output alternator. So this little white rheostat in there, that will adjust the output voltage, I believe from like 13.8 to like 18 volts. So this can like charge a 16-volt battery. It just needs adjusted. I'm gonna attempt to adjust it into a window where the car is seeing probably like 14.5 volts, somewhere in there, just to keep everything happy but not like stress it too much. So we'll see how that ends up going. That is the plan. All right guys, real quick, I did forget to mention this is a smaller alternator, yes. The amperage output is slightly smaller as well. I'm hoping it'll still fall into a good range for the car, since we are on mechanical fuel pump. You know, that's a big amp draw, so we don't have that, and tons of stuff's deleted. So hopefully we stay okay with this. That is the only variable. So I may have to adjust this and do a new bracket. If so, so be it. Still a good learning experience at the end of the day. I believe the factory output is around 90 amp is what they're rated. If I do recall, back in the day, I put an inductive amperage clamp on my post here, and it was only like 58, 60 amps when it was running. But this guy is rated for 75 amps, so 15 amp difference. Fingers crossed it will work. So yeah, I just wanted to mention that. They do make a slightly bigger one of these that's 110, 120 amp. That's, I think, still smaller than this. I will have to double check on that. But just want to throw that in there real quick. Thanks so much. All right, guys, here she is, all finished up. I did have this face countersunk because that bolt did barely touch the alternator. I got it all painted at work the other day. I left some spots off so that if the alternator does still need to ground via the engine, it still has that capability to. So this guy just bolts on just like this. Everything lines up good. I'm super happy with how it turned out. We're gonna get it put on the car here in a little bit and go from there. So thank you so much. That's probably gonna end off this video. We got some other stuff going on. That's gonna be another video. We got a lot of stuff going on, personal life and with the car, work, everything. So I'm just gonna leave it at that. Thank you guys for watching, and we will see you next time. Peace out.